Hi, my name is Daniel Henry, and I'll be presenting to you today Calculus 2 and Finance and how we use series to compute interest and bond yields. I'll talk more about what that stuff is later and what it means. So, the introduction math in the real world. Every day I hear people say, when will I use this in life? What importance is this math class to me? When will I ever use integrals, derivatives, things like that regarding math? And they tend to attack the use of calculus, which is a little bit of more complex math because algebra is seemingly easy to realize what you're using it for in the real world. But they also attack the lack of finance classes in school, like, oh, I don't know what interest is, how do I compute my mortgage, things like that, being unprepared for the real world and how complex finance is as a whole. Like, oh, these banks are just trying to get money out of me for no reason, take all my money, which may not actually be true. So, first, we'll talk about interest, which is the main point of today. So, what is interest? Well, when you take a loan from a bank, so they give you some amount of money, let's say $1,000, you take the $1,000 and throughout time, you'll need to pay that $1,000 back, of course, but the bank also needs to make some kind of money to keep them going as well, which is where you pay interest. Now, interest is just a percent or a fraction of whatever money you just lent that you pay the bank in addition to the initial amount so that they can have a profit from the whole situation as well for giving you money in the first place. Next, we're brought to compounded interest. So first, let's just talk about interest with savings accounts. So you put money in, say, once again, like $1,000 you put into a savings account. The bank lends money to other people and then charges them interest, like we discussed, for profit. And then you get a share of that profit since the bank actually lent your real money. Because the bank doesn't just have infinite stores of money for themselves. They just have stores of other people's money. So what they're doing is they're lending that money to other people, making money off of it, and then giving you a small percentage of it, very small actually, but so that you can also make money off of the money you've given to the bank. So make money off of your own money. That's usually what is a savings account. It's usually a very small percentage, but for this case, it helps me explain the topic. So, what's compound interest? Well, so we discussed sorry. So we discussed interest as a whole. Now, what does it mean to be compounded? Say you have like an initial amount of $100. The interest rate on that money you put into the bank. So you put $100 into the bank, and the bank gives you an interest rate of 10% on that $100 annually. So every year you get 10% of whatever's in the bank, and you get to make that for yourself as a profit since the bank's lending your money. So compound interest isn't just a one-time thing. Oh, here's $1,000. I get $10. No, that's not how it works. What it is every time you get a percent of profit, as you see here, like the first year you get 10% of $100, which is $10 profit. Your new amount is actually $110. So that second year, since it's compounded interest, you get 10% of your now $110 since the profit was added to it, which now brings you an $11, gives you a new total amount, and then you put it in again for a third year, get however much of that, and then it keeps growing basically. That's what compound interest is. So it keeps giving you a fraction of itself, even with the new totals. So I've talked about interest and whatever it is, but how can we use series to help us compute, use, visualize, and everything with interest in our money? So the main series we'll be talking about today is a geometric series. And as you see, I wrote the general formula, which is the sum of an initial value, which in our case will be your initial money you put in. The R, which in this case will be the rate of interest, which will be usually a percentage, but then once we use it in the equation, it'll be a fraction. And then N, which in this case will be time. So you've really got to worry about how much about when your interest is being compounded. So say they could do it by month, they could do it quarterly, which is every 3 months, fourth of a year, or they could do it annually, so every year. So you really got to be careful and take that into consideration whenever you come up to a problem with it. Speaking of problems, here's our first example here that I wrote out. So say you buy a single share of stock in Disney. The cost of the share is $12, and every year the value goes up 8%. How much is the share worth in 2043? So first of all, it's 2018. That's 2043. You realize that it's 25 years. So we know that we'll hold this share of stock for 25 years. And at 25 years, we want to find out how much our initial stock purchase is now worth, since it's grown every year. So as you see here, our initial value, $12, because that's how much we put in. We bought one share. And then the rate in this scenario, while it does say it goes up 8%, you have to realize that that 8% accounts for the original amount too. So it's 1.08 rather than just 0.08, because you're not decreasing. You're not taking 8% of your $12. You're adding 8% of your $12. And then our time in this case will be 25 years. And as the problem says, it's annually. So every year the value goes up. So we won't have to worry about conversions. So now to solve this, we use our general formula, which I had in the other slide, which is just the sigma of the initial times r to the power of n. So plug in our values. We've got our 12, and then we've got our 1.08. So first you take the 1.08 to the power of 25, because it's 25 years. And then you multiply that to 12, which gives you $82.18 about, because there's some other decimals thrown in there. But that's how much your initial $12 value will be worth in 25 years if it continuously grows at 8% a year. Which actually, that's a pretty huge investment. That's 7 times the original amount. So imagine if you bought a real amount of shares in that. Now, we've gone past the easy stuff, geometric series, blah, blah, blah. Anyone can do that. Taylor's series, however, is a little more of a difficult topic in Calculus 2, at least it was for me. And Taylor series is actually used in finance as well, which I didn't know until this project. So Taylor series actually kind of involve bonds. So bonds, it's just a statement, kind of like an IOU the government issues to banks. And in exchange, the banks pay the government for this, but obviously the banks want something out of it. So the government will give them interest on the bonds that they purchased from the governments, give the banks interest. So it's basically just like any other investment. You put money into it, someone else holds your money, you get percent earnings or yields off of that. So a bond's yield, as I said, is your return on investment from a bond. And a current yield can be calculated by annual earnings over the current market price. Because with bonds, as you know, the market fluctuates, so does the actual bond price. It's just like with a stock in a company. Say you buy something for $1 one day, the next day it could be $30 a share. It's really kind of fluctuating. And then we also know that it's a nonlinear relationship between yield and a price of a bond. So that's why we can use this equation that I show in my next slide here. So the fluctuation can be written as a Taylor series with P1 equals P initial plus F prime of Y of 0, blah, 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 blah. P1 is your new price. P initial is obviously the initial price of the bond. And then Y is the yield of the bond, how much it's worth at that time. Obviously, Y of 0 is the initial yield, so how much you're supposed to be making from the bond initially. Change in Y is the change in yield from now since the beginning. And then the function F prime of the yield is the change in price relating to the yield, because it's derivative, so change over time. And then double prime obviously is the change of the yield, and so on throughout the Taylor series. So most people will use that equation in quantitative economics, which are pretty much people that create algorithms that kind of track the market numerically and predict results or estimations from current market trends due to equations such like these. So someone can take this and then they'll guess how much the price will be.